Nowadays, differentiations are made between polygenic disorders and oligogenic disorders. Oligo simply meaning more than one gene, but not a huge number. It's not a sharp cutoff, but disorders like schizophrenia or autism probably are not polygenic in the sense of hundreds of different genes. They probably involve maybe a dozen different genes, but not vast numbers. And that what one has to understand is the different ways in which they play a part in the causal process. So that, for example, one of the key issues is, let's suppose for the sake of discussion that there are 4 genes concerned. One question is, do they all impinge on the same causal pathway, or do they bring about the disease or disorder through different routes? And we don't know that, but it does mean that the research has got to look at both sorts of possibilities. The traditional notion is that each gene has only one protein product, but actually it turns out to be more complicated than that. To begin with, the whole process by which genes, meaning the DNA, affect the RNA, which then affects gene expression, affects proteins, affects the folding, involves many DNA elements. So there's not just one gene, there's, if you like, a whole family of genes, all of which are playing a part, and in which environmental factors are also playing a part in that. So it's a dynamic concept now in a way that it didn't used to be. And that means we must take on board in our research in molecular genetics the possibility that we should be focusing on just genes for schizophrenia or autism, but for subvarieties, so that one might be looking at genes that are concerned with the social aspects of autism, and different genes concerned with repetitive behaviors, and different genes concerned with communication. Suggestions have been made that that is happening. The evidence, to my mind, is still a bit contradictory, but there's no doubt it could work like that, and the research must take on board that as a possibility. Coming back to the point made earlier, genes don't code for diseases. They code for proteins, for chemicals, which play a part in the development of disease, but they aren't the disease as such.